In the problem, we are given box A and box B, both with acceleration to the right. Acceleration is the same for both boxes. Box A is at an incline of 55 degrees, while box B is at an incline of 25 degrees. Box A is being acted upon by force A at 100 newtons in the vertical direction. Box B has been acted upon by force B at 250 newtons along the incline. We're given a static friction coefficient of 0.63 and a kinetic friction coefficient of 0.33. Mass A is 30 kilograms, while mass B is 50 kilograms. You draw in the free body diagram for box A, we get force normal. Also, force A cosine theta in the y up direction, mg cosine theta in the y down direction, as force A and mg can be drawn at 55-degree angles of the 180-degree plane given by the inclined surface. In the x direction, we are given the force of tension, again along parallel to the inclined surface, and force A sine theta at 55 degrees. Going back, we have mg sine theta and the force of kinetic friction acting as A is being dragged along. It's acting in the opposite direction of A, where A is moving. All right, the free body diagram for box B is in the y up direction, only force normal. In the y down direction, mg cosine theta, as once again mg is straight down while the inclined surface is at 25 degrees. In the x right direction, we have force B at 250 newtons, mg sine theta, and then acting opposite of that is again the force of kinetic friction acting opposite, and force of tension acting opposite. All right, using F net equals ma, in the x direction, we're given mass of A times acceleration equals the force of tension plus Fa sine theta minus mag sine theta minus force of friction. In box B's case, in the x direction, mass of box B times acceleration is equal to force B plus mg sine theta B minus the force of friction minus the force tension. In the y direction, since neither boxes are accelerating upwards or in the y direction, F net equals m times 0 for y. Because of this, the y direction can be written as force normal plus Fa cosine theta minus mg cosine theta equals 0 in A's case. Solving for force normal, we're given force normal equals m mass of A g cosine theta minus force A cosine theta. Let's go ahead and solving for force normal using F net equals ma. And for B's case, solving for force normal, you're given mass of B times g cosine theta. This will be used in our force of friction as force normal times our friction coefficient for kinetic friction equals the force of friction. So using the F net equation in the x direction for A, solving for Ft then equals negative force A sine theta plus mass of A g sine theta A plus force of kinetic friction and plus mass A times acceleration. In B's case, we are already given the same equation up here, but now we have ft and what ft equals. So we take this and plug it into this ft, now given this. Mass of b times acceleration equals fb plus mass of b times g sine theta minus force of friction on b plus force A sine theta minus mass A g sine theta A minus force of friction on box A minus mass of A times acceleration. From here on is the same equation we were given for Ft, except for all the signs are flipped, as in B in the x directions equation, it's minus Ft. So we can now take this negative ma times acceleration, mass of A times acceleration, and add it to the beginning of the equation to get ma plus mb. Now I went ahead and divided this entire equation without ma times acceleration by ma plus mb, factored out of mba plus maa. So that now gives us a equals our original b equation divided by ma plus mb, plugging in all of our numbers from the beginning. We are now given, and substituting force normal, what force normal equals, times our coefficient of kinetic friction. Same thing over here. We're given an A of 1.43 meters per second squared. Now, taking our original, you can use either the A or the B equation, but whatever force tension equals in your equation, plugging A in with the rest of our numbers in this equation, you can now solve for force of tension, as I did here, for 238.84 newtons. What David did wrong in his problem was he did not account for FA not being perpendicular to the inclined surface. So FA is at a 55-degree angle instead of perpendicular, meaning you have to account for FA cosine theta and FA sine theta. He also did not include in mass of A g sine theta A when he plugged into his B equation. For whatever reason, he just did not include this part right here. So he was missing a part of his equation, which was already wrong, as his force normal was kind of screwed up from not having FA cosine theta and FA sine theta. And lastly, his acceleration was written in units of meters per second when acceleration is meters per second squared. Yeah, I tried to condense the entire thing down as much as I could to one page to be able to explain it. Thank you.